The alarming scenario of global warming is striking people to increase the use of green energy, such as wind turbines. For reaching the net zero emission scenario by 2050, the International Energy Agency estimates that the current wind power generation of about 1600 terawatts hour should reach up to 800 terawatts hour until 2030, which means an average increase of wind power generation of almost 18% per year. As of any machine, wind turbines are subjected to wear and failure, which requires maintenance of the equipment. In this context, gearboxes are pointed out as critical components, being responsible for about 30% of wind turbines' downtime. Therefore, the development of techniques for the condition monitoring of gear damage is required to reduce maintenance costs, and, by consequence, to increase the competitivity of wind turbines in phase to non-renewable energy sources. My PhD thesis is combining efforts from the Laboratory of Tribology of the Federal University of Rio Grande do Sul in Brazil and from the SUTA Laboratory of the Ghent University in Belgium. According to the latest Global Wind Report from 2021, both countries have significant shares of world's wind power generation. In the onshore scenario, Brazil stands up with 3% of the total wind power produced in the world. Meanwhile, Belgium accounts for 6% of the total offshore power installation in the world. In my research, I will be conducting experiments in an FCG gear test rig. This equipment can be used to perform accelerated lifetime tests of gears. The experiments will be conducted in such a way that we will be able to reproduce the same types of gear failures that are experienced in the wind turbines application. The major goal of my research is the development of a technique for the monitoring of the gear surface damage. This technique consists of the implementation of a surface monitoring system that will allow us to see the defects in the gear surface. This is allied to the design of tailored analysis indicators that will objectively quantify the damage of the gear surface. Therefore, the outcome of this research is likely to increase the feasibility of wind turbines in the generation of green energy, which is of vital importance for our future.